The data revolution is transforming society through the use of emerging technologies, such as machine learning and artificial intelligence. These technologies are also helping our doctors make better decisions, but require clean, organized, usable data. In a hospital, many different information buckets exist. There's a bucket for patient registration, pharmacy data, lab results, and so on. These buckets exist as separate source systems and are constantly being added to. To enable advanced analytics, these data need to be cleaned and organized. Mapping a patient's hospital journey from one source system to another can be very difficult, and pulling meaningful data together for a report can take months. An enterprise data warehouse was built at St. Michael's Hospital to bring this rich but disparate hospital data together in one place, in a more meaningful and integrated way. The database is comprised of 3 layers: raw staging layer, atomic layer, and a dimensional layer. The first layer is the raw staging area. Copies of data from the information buckets are dumped into this common area every 24 hours in their original form. The data is still disconnected and not in a structure that is conducive to analysis. You can think of it as a data holding tank. The connections between the different pieces of data are made in the second layer, called the atomic layer. It's here that data are extracted and broken down into discrete bits of information and then transformed into a highly normalized data structure. The data are reorganized so that they're linked together, optimized for storage, and absent of duplicate data. In other words, all of the data about a patient's journey are getting pulled out and woven together to tell a coherent story, like a data spider web. While the atomic layer contains lots of cleaned, linked data, not all of it is relevant for analysis, and long chains of linked data can be difficult to analyze. This takes us to the third dimensional layer of the database, which contains the data from the atomic layer that is accessed most frequently. Data in the dimensional layer are repackaged to allow for more efficient data queries into a Star-Schema data structure, because of its resemblance to a star-like structure. In the middle of the star is the fact table. A fact table holds information about things you can measure or count, and every row of a fact table is a different instance of that event. For example, the emergency encounter fact table is a record of all emergency visits that have occurred in the hospital, and each row of that table represents a single emergency visit. Consequently, a patient who has many emergency visits will have many rows of data in this table. Branching out from the fact table are dimension tables. These are the arms of the star structure. Dimension tables hold the contextual data associated with fact table events. They describe the who, what, where, when, and how of each of those events, and link to fact table rows via a matching ID key. For example, the emergency encounter fact table links to a practitioner dimension table, and it's here that you would find all the details about the physician associated with an emergency visit. It also links to a patient dimension, who is the patient, and an arrival mode dimension, how did the patient get to the hospital. This warehouse of fact tables and dimension tables, data spider webs, and data buckets is enabling cutting-edge analytics at St. Michael's Hospital to improve outcomes for the patients we care for.